Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this is set 3 of 10 good problems on the chapter of Algebraic Expressions and Identities. If you have not watched the first two set problem solving, I highly suggest and I request you to watch those videos also. That will give you a good practice of your understanding on the chapter of Algebraic Expressions and Identities. So this video is part of the playlist Maths 8 HOT. HOT stands for High Order Thinking Problems, where I come up with relatively harder problems from external sources, which are harder. These problems are harder than the uh, problems that we solve from the textbook of author R.S. Agarwal. So if you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel. And also please do not forget to press the bell icon so that you will be notified by my future videos. So let's get started in solving the set 3 of 10 good problems from the chapter of Algebraic Expressions and Identities. Okay, so I have the 10 good problems question paper on the left hand side. Ideally, so these are all MCQ problems where one choice will be correct, and you should take approximately 3 or 4 minutes to solve a question. So the entire problem set must be completed in within 40 minutes. It is recommended that you first try to solve the problems yourself. Only when you are stuck, then you see this solution video as a reference. So after solving a problem, I will pause for a few seconds so that you can take a screenshot of the solution if you think it will help you. Let me quickly check if everything is visible or not. I hope the problems are big enough for you to see. The PDF of the problems will be given in the description below. Okay, so let's start solving the problems. Okay, so the first problem says it is given root 3 into x plus root 5 into y is given as 9, and also it is given xy is equal to root 15. Then we have to find the value of 3x square plus y 5y square. Now we have to find the value of this expression 3x square plus 5y square divided by root 3x plus root 3x minus root 5y. Okay. Uh, Now these two facts are given. These two facts are given. We have to find 3x square plus 5y square. Now 3x square plus 5y square is is equal to root 3x, the square of root 3x, and plus the square of root 5y. So we are having a kind of a square plus b square. We have to find the value of a square plus b square, and as you can see, if you consider this as a and we consider this as b, we are having a square plus b square. That we have to find the value of a square plus b square where a plus b is given. So if you consider if you consider root 3x, this is just for the sake of understanding, and a, and root 5y as b, then as you can see, a plus b is given as 9, and we have xy is also given as root 5. x5 is also given as root 5. Now you must be very familiar in finding the value of expression a square plus b square when you are given a plus b and ab, or or you are given a minus b and a and b. If you are given a plus values of a plus b and ab, or values of a minus b and ab, you must be able to find the value of a square plus b squared. So this is how do we find a square plus b square. We can express a square plus b square either in terms of a plus b and ab, or a minus b and ab. Since we are given root 3x plus root 5y, we will consider this expression. This is a kind of identity. A square plus b square is equal to a plus b whole square minus twice a b. This is nothing but it is coming from the fact that a plus b whole square. From the identity of a plus b whole square, I have just moved the twice ab from the left hand side to the right hand side. So we know this. For any number a and b, we have a square plus b square is equal to a plus b whole square minus 2ab. Now we can say that from applying this identity, we can say that root 3x square plus root 5y square will be equal to root 3x plus root 5y whole square minus twice of ab, that is root 3x multiplied by root 5y. Now the right hand side is equal to root 3x plus root 5y. The value is already given to be 9. So this is 9 square, and minus 2 into root 3x into root 5y is equal to 2 into root 3 multiplied by root 5, and we have x y. Now this is equal to 81 minus root 3 into root 5 is root 15, and xy is given as root 15. So this is becomes equal to 81 minus 2 into 15. This is equal to 81 minus 30, which is equal to 51. Okay, so we have got the value of so this implies that 3x square plus 5y square is equal to 51. Now we have to find the value of root 3x minus root 5y. Okay, so we have to find the value of root 3x minus root 5y. Now also you must be familiar with these identities, that a minus b whole square can be expressed in terms of a plus b, that is, it is a plus b whole square minus 4ab, and also you can say from this identity only, you can also express a plus b whole square is equal to a minus b whole square plus 4ab. So this is the relation between a plus b, a minus b, and a into b. So we can say that root 3x minus root 5y square is equal to root 3x plus root 5y square minus 4 into root 3x multiplied by root 5y. So this is equal to root 3x plus root 5y, we are given as 9. So this is equal to 9 square, and this is equal to 4 into root 3 into root 5 into x into y. So this is equal to 81 minus I think I have okay, so let's see. 81 minus, now we have 4 into root 15, and xy is, the value of xy is given as root 15. So this is equal to 81 minus 4 into 15. This is equal to 81 minus 60. This is equal to 30. This is equal to 21. This is equal to 21. Okay. So this implies that root 3x minus root 5y is equal to, we have found the square of root 3x minus root 3x minus root 5y whole square is equal to 21. So root 3x minus root 5y will be square root of 21, and hence we have found root 3x minus root 5y, and also we have found 3x square plus 5y square, that is this. So we have found both the numerator and the denominator of the given expression. So this implies 3x square plus 5y square divided by root 3x minus root 5y is equal to 51 by square root of 21. 51 by square root of 21, and hence the correct choice is D, is the correct choice. So all these formulas, that is expressing a minus b whole square in terms of a plus b whole square and ab, and vice versa, you must be very familiar with. Okay. Let's do problem number 2. It says that the polynomial p when divided by ma plus nb gives a quotient a minus b and a remainder a plus b. Then p is, okay, so p is a polynomial, and it is a polynomial. It is when divided by ma plus nb, it is like, okay, so when the polynomial p is divided by, we know that in general when we divide a number, let's say y, by x, and let's say the quotient is q, and we have some, finally the remainder r, we can say that y is equal to xq plus r, that is divisor into quotient plus remainder is the dividend. So in this case the dividend is the polynomial p, the divisor is, so in this case the divisor is ma plus nb, and the quotient is a minus b, and the remainder is a plus b. So we can definitely say the polynomial, which is the dividend, will be equal to divisor multiplied by the quotient, that is a minus b, plus the remainder, which is a plus b. So now we have to find the product of this product and the summation of algebraic expressions. So ma plus nb multiplied by a minus b using the distributive law of multiplication over over addition, we get this as ma into a minus b plus nb into a minus b, and we have a plus b. Now again we have to find the product of monomial and a binomial. So ma into the product of monomial ma and the binomial a minus b becomes m a square minus m a b, and the product of the monomial nb and the binomial a minus b becomes n a b minus n b square, and we are a plus b. So NAB minus, okay, oh, this equals MA plus NB, MA plus NB multiplied by A minus B. Let me check if it is correct or not. MA A minus B plus NB A minus B. Okay, and then we have MA square minus MAB plus NAB minus NB square. A minus B. A plus B. The result we are having is will not match with any of the given choices. But I think I did some mistake. So as you can see, I always do some mistake in preparing the questions for in this series of videos, 10 good problems, because some of the problems are framed by myself and some of the problems are taken from the book. So while framing a question, I do some mistakes in giving the choices. So this problem was framed by me, and when I was solving the problem myself, I thought MAB and NAB will cancel out, but actually this is MAB and this is NAB, so it is not cancelling out. Consider if these two terms were cancelled out, if they were cancelled out, then we would have got M. Then we would have got no, I think all the choices are wrong. All the choices are wrong anyway. So my mistake. I solved this problem in a wrong way. So that's the reason I gave wrong choices. It is my mistake. So this is the correct answer. That is now you can possibly rearrange this in a simplify this. It will not get simplified further, but M B no. So this is the answer. I mean, you can possibly take some common and do some further simplification, but that is not the important thing. The important thing was to understand the question and solve it and get the correct expression. Now you can simplify the expression further. That is not a big problem. It is not that important. The concept was to the main objective of these 10 good problems is that you understand the problem well and you apply the correct algebraic identities, and you apply the addition, subtraction, multiplication and division of algebraic expressions correctly. So that is the main objective of making these 10 good problems. So I think this is the answer. Probably this can be the answer. A, B. No, I think this cannot. I mean, it will make no sense to further simplify this expression. So I will leave it here. And sorry for giving wrong choices. Let's proceed with the next question. The next question. It is given that y is equal to x minus 1 by x whole square, and it is also given x square plus 1 by x square is equal to 29. Then units digit of y square. We have to find the units digit of y square. So for that, definitely we have to find y. We have to find y. Okay. Now what is y? Y, if I expand, y is given as x minus 1 by x whole square. So applying the identity of a minus b whole square, this becomes x square plus 1 by x square minus 2. So it will be a square plus b square minus 2 into ab. So this is the expansion of x minus 1 by x whole square. So this becomes x square plus 1 by x square minus 2. X square plus 1 by x square value is given to be 29. So we have 29 minus 2 is equal to 27. Okay. So we have found y equals to 27. Now what is y square? Y square is 27 square. Now from the chapter of squares and square roots, you know that if a number ends with the digit 7, then definitely its square will end with the digit 9, because 7 into 7 is 49, and the units digit of uh, 49 is 9. Hence uh, units digit units digit of y square is actually equal to units digit of 7 square, which is equal to 9, so the correct choice is D. D is the correct choice. Okay, let's do problem number 4. It is a simplification problem. X by 5 minus 5y whole square plus 5y plus x by 5 whole square. We can clearly see it is of the form a minus b whole square plus a plus b whole square, where if you consider this as a and this as b, it is of the form uh, a plus b whole square plus a minus b whole square. And you should know that even though you can expand the x minus a minus b whole square and a plus b whole square, you can find what is the result expression, but you must be very well aware and familiar that a minus b whole square plus a plus b whole square is always 2 into a square plus b square. So we will have this equal to 2 into x by 5 square plus 5y square. Uh, Excuse me, friend. Somebody is at the door. Please give me a few minutes. I'm sorry. Okay, friends, I'm sorry for this delay. Unexpectedly, there was someone at the door. I'm sorry. Okay, so we were solving. Uh, okay, so we have this. Okay, so now, okay, so this is 2 into x square by 25 plus 25 y square. So, so it is matching with the choice D. So this was a pretty straightforward question. Uh, you just have to know, if you know that a minus b whole square plus a plus b whole square is equal to twice into a square plus b square, you can save some time. If you do not, if you don't know this formula identity, then you can always do the expansion of a minus b whole square and a plus b whole square, and you will of course get the same result. That is, it will be equal to twice of a square plus b square. Okay, let's do problem number 5. The product of a monomial and a binomial is a monomial, binomial, trinomial cannot be said. Okay, the product of a monomial now and a binomial. Now, so it is of the form A multiplied by B plus C. So B plus C, this is will be a binomial where of course B and C are some terms. This is a binomial and this is a monomial. This is a monomial. Now, always keep in mind that if B plus C is a binomial, it is a binomial. That obviously means that the terms B and C, they are not like terms. They are unlike terms. They are this fact. This fact implies since B plus for a binomial is a polynomial of two terms, where the two terms are unlike. They are not like terms. If they were like terms, they would have got merged, added to give a single term. So this implies that B and C are unlike terms. Are unlike terms. Are unlike terms. And A is a monomial, so it's a single term. A is a single term. Now the concept is when so A into B plus C is equal to A into B plus A into C. Now since B and C are unlike terms, B and C, this and this, they are these two terms, that is A into B and A into C, they are unlike terms. They are unlike terms because A into B has a common factor A, and A into C also has a common factor A. But since the factor since the B and C are unlike terms, if you multiply two unlike terms with a monomial, then the results will also be unlike terms. So we will definitely have A into B and A into C are unlike terms. If this is so, then of course A into B plus A into C will be a binomial. This will be a binomial. It will be a binomial because we clearly see it is having two terms and the two terms are unlike. And hence the correct choice is B. Product of a monomial and a binomial is always a binomial. Okay, let's do problem number 6. A square wall of side length 2a plus 3b has a rectangular door of dimension a plus b by a minus b. Then the area of the wall, that can be painted is a square wall. Let's try to visually draw what is given. So let's say this is the square wall and each side is 2a plus 3b. This is the length of each side. Okay. It has a rectangular door of dimension a plus b by a minus b. So let's say this is a rectangular door, and obviously this length, this must be a minus b, and this length, this is a minus b, and this the height must be a plus b. So this has a rectangular door of dimension a minus b, a plus b by a minus b. So then the area of the wall that can be painted. So definitely the area of the wall that can be painted is the area of the wall square minus the area of the rectangle. The shaded area region is the area that can be painted. So area of wall, since it's a square wall, its area will be side square, the length of the wall square. So it will be twice a plus 3b square, and the area of door, area of the door is equal to a plus b multiplied by a minus b, which we can apply directly the identity of a square minus b square. So this will be equal to a square minus b square. So area to be painted, or that can be painted, area of the wall that can be painted will be equal to area of the wall minus the area of the door. So that is twice of a plus 3b whole square minus of a square minus b square. Now we have to simplify this expression. If you expand 2a plus 3b whole square, this is 4a square plus 9b square plus 12ab, and if I open the second bracket, I get minus a square plus b square. Now if you simplify this expression, that is adding the like terms, we get 3a square plus 10b square plus 12ab. This must be the area, and we are not having this expression in the choice 3a square. 3a square is b, choice b, twice b. Oh, so the choice is given in a little different way. So if you can take from 10b square plus 12ab, you can take 2b common. If you take 2b common, we are left with 5b plus 6a. So this is the area that can be painted, and hence the correct choice is B. B is the correct choice. Okay, let's do problem number 7. It is given x plus y is equal to 10, and it is given xy is equal to 9. Then we have to find the value of 1 by square root of x plus 1 by square root of y. X plus y is given, xy is given. So from this x plus y and xy, we can definitely find the value of x. We can find the value of now the given expression is root x. We are having root x and root y. Root x and root y. Okay. Root x. Now what is now 1 by root x plus 1 by root y. If I simplify this, we get this has to be root x plus root y divided by root x into root y. We just do the LCM, that is addition of two numbers or rational numbers. Now this is equal to root x plus root y divided by square root of x into y. We know the value of x by 9. Okay. we somehow need the value of root x plus root y. Root x plus root y. We are given x plus y. Okay, so x plus y is 10. Now x can be thought of as a square of root x. Square of root x. Y can also be thought as square of root y. So this is given. Hmm. So we have to find somehow root x plus root y. We have to find this a plus b, kind of a plus b, where we know a square plus b square is equal to 10. That is, we know that square of root x plus square of root y is 10. So how do we find a plus b from a square plus b square? Also we know x into y. That is, if we know x into y, we can also find root over x into y. Okay. Now, okay. So root x plus root y square, if I do square, this is equal to, I know, root x square plus root y square plus 2 into root x multiplied by root y. Now root x square plus root y square, we know the value is 10, and this we have 2 into root of x y. So this is equal to 10 plus 2 into root of xy is given as 9. So this is equal to 10 plus 2 into 3. So this is equal to 16. Okay, this is 16. So this implies that root x plus root y will be equal to square root of 16, that is equals to 4. Okay, I think we are done. So we have root x plus root y. Now divided by, you have to find this. This is equal to root x plus root y is 4, and square root of xy is 9. So this is equal to 4 by 3. 4 by 3 should be the answer. Okay, and we see the correct choice is D. D is the correct choice. Okay, let's do problem number 8. If the area of a circle is 108 by 112 multiplied by 7 plus square root of 48 area, then circumference is okay. So area of a circle with radius r is, we know, is equal to pi r square, and always consider pi as to be 22 by 7. I think the problem does not say anything about pi, the value of pi. You can consider the value of pi as 22 by 7. As you can see, some choices are having 22 by 7. So we know that the area of a circle with radius r is pi r square. That is 22 by 7 multiplied by r square. So if so the area of a circle is given, so if we consider the radius to be r, we are having 22 by 7 r square. So this we can say consider as 108 by 112 multiplied by 7 plus square root of 48. Okay, now so this implies r square will be equal to 7 by 22 multiplied by 108 by 112 multiplied by 7 plus square root of 48. This equal to, I think we have to do some cancellation. 22, 9, okay, 9, 18, okay. So this cancels 108 with 9. and 7 divides 112 with 1 4. Okay, so this 16. Okay, so this is 9 by 16 and 7 plus square root of 48. We have to find r because we have to find the circumference. Circumference is equal to 2 pi r. 2 pi r. We have to find r. So somehow this expression has to be expressed in terms of a square. Square of something. Square of something. Now this we can 3 is 3 square, 9 is 3 square, and 16 is 4 square. 48. So this we can write it as 3 by 4 square, and we are having 7 plus 40 square root of 48. So somehow we have to express 7 plus square root of 48 as a square of something, as a square of something. So let's see what we can do with 7 plus square root of 48. This is equal to 7 plus 7 plus 7 plus. So if you can think that this can be expressed as some a plus b whole square, then a square plus b square. If you can compare this, if you can somehow find some a plus b such that a plus b whole square is equal to 7 plus square root of 48, let's say a square plus b square plus twice ab. We have to eventually we have to find we have to express 7 plus square root of 48 as a square plus b square plus twice ab. So what can a and b be? A square plus b square. Square root of 48. Square root of 48. We need 2. We need 2 twice ab. So definitely twice ab must be square root of 48. Now square root of 48 we can take 4 common. It will be 4 into 12. And okay, so this is square root of 4 into 12, and this is equal to 7 plus square root of 4 into square root of 12. This is equal to square root of 4 is 2. So this is equal to 2 into square root of 12. 2 into square root of 12. So this means that AB has to be equal to square root of 12. Now AB has to be square root of 12. Okay. Now such that a square plus b square is equal to 7. Now what can the value of a and b be such that ab is equal to square root of 12? How can we factorize? I mean, how can we factorize 12 as two numbers a and b such that ab is equal to ab is equal to square root of 12, and also a square plus b square will be 7. Now 12 is 4 into 3. Okay, so 4 into 3 my part. If I consider square root of 12 as square root of 4 and square root of 3, this implies that a you can consider a as square root of 4 and b as square root of 3. So this will imply obviously a square plus b square is equal to 4 plus 3 equals to 7. So we can consider a as a square root of 4 and b as square root of 3. So this thing can be considered as so 4 7 is 4 plus 3, and we have 2 into 12. A square root of 12 can be written as square root of 4 multiplied by square root of 3. So now this is 4 can be written as a square of square root of 4, and 3 can be written as square of square root of 3. So now we get the form of a square plus b square plus twice ab. So this is equal to square root of 4 plus square root of 3 whole square. Okay. So what is r square now? So this implies r square is equal to 3 by 4 square multiplied by square root of 4 plus square root of 3 whole square. This is equal to 3 into square root of 4 plus square root of 3 divided by 4 whole square. Now we can say that R then definitely must be equal to 3 into square root of 4 plus square root of 3 divided by 4. Now circumference, this implies circumference is equal to 2 pi r. Now pi we can consider as 2 into 22 by 7 and r is 3 by 4 multiplied by square root of 4 plus square root of 3. If you do cancellation, 2 divides 4 with 2 and 2 divides 22 with 11. So this becomes 33 by 7 multiplied by square root of 4 plus square root of 3. 33 by 7 square root of 4 plus square root of 3. Oh, so square root of 4 is 2. So this is equal to 2 plus square root of 3, and hence the correct choice, this is the circumference, the correct choice is C. C is the correct choice. Okay, let's do problem number 9. The expression, okay, so an expression is given where it is a product of some monomial and binomial and their subtraction and addition has a degree of. We have to find the degree of the given expression. So first we have to simplify. So the given expression is 4st multiplied by s minus t minus 6 s square plus t minus t square and minus 3t square multiplied by 2 s square minus s plus twice of st multiplied by s minus t. So these are basically all products of monomials and binomials. So this will be equal to 4 s square t minus 4 s t square. This will be minus 6 s square t plus 6 s square t square, and then minus 6 t square a square plus 3 t square s plus 2 a square t minus 2 s t square. Now we have to further simplify, that is see whether we are having like terms or not. We will have to add the like terms. Let's see is a square t. Let's add all the terms with the literal coefficient is a square t. Is a square t. I will quickly check once again if I did the multiplication correct or not. So 4st is minus t minus 6 square t minus t square minus, okay. Okay, so 4 s square t minus 4 st square minus s 6 s square t plus 6 s square t square minus 6 t square s square plus 3 t square s, okay, plus 2 s square t and minus 2 s t square, okay. So let first group the like terms. 4a square t minus 6a square t plus 2a square t. Okay. Then let's group the term s t square. So we have minus 4 s t square and we have plus 3 t square s and we have minus 2 s t square. Now let's see the term a square with the literal coefficient t square a square. So we have 6 a square t square and minus 6 t square a square. Okay, so how many terms we have? 1, 2, 3, 4, 5, 6, 7, 8 and 1, 2, 3, 4, 5, 6, 7. Okay, so all are covered. So now if we add up the like terms, we get so this all these terms gets cancel out and this also gets cancelled out. So the result is minus 6, it is minus 6 s t square plus 3 t square s, which is equal to minus 3 s t square. So the simplified expression is a single term monomial, which is minus 3 s t square, and this has degree. It is asked the degree of the given expression. So, degree of a polynomial, a monomial, is the degree of the term itself. And what is the degree of a term? Degree of a term is the sum of the powers of the variables present in the term. So in this case, we are having the variable s and t square. So their sum, the power of the sum is 1 plus 2. So the degree of the given polynomial of the given expression is 3. It's 3. So the correct choice is B. B is the correct choice. Okay, so this problem was based on finding the product of a monomial and a binomial and then adding up the like terms, and then finally the concept of degree of a polynomial, which is based on the fact of degree of a term. Now degree of a polynomial is the maximum degree of the terms in the polynomial. The term having the maximum degree in the polynomial is the what is the degree of a polynomial? Degree of a polynomial is the maximum degree of all its terms. Okay, let's do problem number 10. Okay, x plus 1 by x is equal to 4. It is given, and find the value of, we have to find the value of x to the power 8 minus 1 by x to the power 4. Okay. Now, in general, the problems which are based on this kind of expression, that is a sum of a term and the sum of a term and its reciprocals, as you can see, x and 1 by x are reciprocal to each other. So in general, this kind of problem can be anything, but they are reciprocal. It could be like not really reciprocal, but sum of two terms, let's say it could be x plus 1 by 2x, that is their product. The product of the two terms will be independent of any variable, that is it will be a constant. So in this case, x multiplied by 1 by 2x is 1 by 2. So this kind of problem the interesting fact is that if you are given the value of a binomial where the two terms in the two terms the literal coefficients are reciprocal of each other. So this could be x plus 1 by 2x. It can also be, let's say, It can also be AB plus 1 by AB, anything. Their product must be independent of any variable. It could be root x y square plus 1 by y square x. As you can see, if you multiply the two terms, that is x y square and y square x will get cancelled out, and the product is square root of 2. So this kind of expression, that is, if you are given the value of this kind of expression, when you take their square, the twice AB term, AB will become always a constant. Okay. So now we have to find x to the power 8. Now x to the power 8 minus 1 by x to the power 4 can be written as if I do the split over the subtraction, this is x to the power 8 divided by x to the power 4 minus 1 by x to the power 4. Now this is equal to x to the power 4 minus 1 by x to the power 4. As you can see, this again, this is a binomial where the terms are reciprocal of each other. That is, x to the power 4 and 1 by x to the power 4 are reciprocal of each other. So this is the catch. Now, what is x to the power 4 minus 1 by x to the power 4? Clearly, we can see a form of a square minus b square, because this is equal to square of x square minus 1 by square of 1 by x square. So now you can see it is like a square minus b square. So this is equal to, if you apply the identity of a square minus b square, which is a plus b into a minus b, this will be x square plus 1 by x square multiplied by x square minus 1 by x square. So somehow we have to find the value of these two. We can easily find it because we know x plus 1 by x. So x plus 1 by x. Now, always remember that, please appreciate this fact that from if you are given something like this, x plus 1 by x, some value is given, from here you can always find the value of x square plus 1 by x square. Also, if you are given x minus 1 by x, from there also you can always find the value of x square plus 1 by x square. That is the catch. So we need the value of x square plus 1 by x square and also the value of x square minus 1 by x square. Now let's first find this. So we know that we have x plus 1 by x is equal to 4. So this implies x plus 1 by x square, if I do square, is equal to 4 square is equal to 16. So this implies, if I take the square of x plus 1 by x whole square, applying the formula of a plus b whole square, it becomes x square plus 1 by x square plus 2 into ab will become 2. Let's do it step by step. So this is, we have x 2 into ab is equal to 16. So this implies x square plus 1 by x square, we have to find the value of this, and we have 2 equals to 16. So this implies x square plus 1 by x square is equal to 16 minus 2, which is equal to 14. Okay, so we have found the value of x square plus 1 by x square. Now how do we find the value of x square minus 1 by x square? So x square minus 1 by x square, as you can see, is also in the form of a square minus b square. Applying the identity of a square minus b square, we know this will be equal to x minus 1 by x multiplied by x plus 1 by x. X plus 1 by x, we already know its value, it is given. Now we have to find the value of x minus 1 by x. We have to find the value of this. Now x minus 1 by x square is equal to, we know you must be familiar in, as I already said, so this is equal to a minus b whole square, I mean a minus b whole square is equal to a plus b whole square, minus 4ab. This you must always remember, so that you can express a minus b in terms of a plus b and ab, or and vice versa. So x minus 1 by x whole square can be, I can say it is equal to x plus 1 by x whole square minus 4 a x into 1 by x. X plus 1 by x is already given. It was a given value, that is 4. So this is 4 square, and we have minus 4. So this is equal to 16 minus 4, which is equal to 12. So this implies x minus 1 by x is equal to square root of 12, which is equal to square root of 4 into 3, which is equal to square root of 4 multiplied by square root of 3, and square root of 4 is 2. So 2 into square root of 3. So we have found x minus 1 by x. So we can now say we know that x square minus 1 by x square is x minus 1 by x multiplied by x plus 1 by x, and we know both the value. So we can now say x square minus 1 by x square is equal to, let's write the formula, this whose value we have already found. So x minus 1 by x is 2 into square root of 3, and x plus 1 by x is x plus 1 by x is already given to be 4. I hope it is given to be 4. Okay, 4. So we have got x square minus 1 by x square to be equal to 8 multiplied by square root of 3. Okay, now so we know this x square plus 1 by x square, and we also know x square minus 1 by x square. So this implies we can say that x to the power 4 minus 1 by x to the power 4 is equal to x square minus 1 by x square multiplied by x square plus 1 by x square, and hence we will now just put the value. X square minus 1 by x square is 8 root 3, and x square plus 1 by x square we have already found to be 14. So this is equal to 112 into square root of 3. Okay, so the correct choice is B is the correct choice. So you have to solve a lot of problems to get used to applying the concepts and how to apply the algebraic identities wisely. So there are certain algebraic identities you must always keep in mind, that those identities should always be at your fingertips, like a plus b whole square, a minus b whole square, a square minus b square, and also expressing a plus b whole square in terms of a minus b whole square, vice versa. And also the formula of cube, that is a minus b whole cube, a plus b whole cube, and a cube minus b cube, and a cube plus b cube. Okay, so this brings to an end in solving the 10 good problems of set number 3 on the chapter of algebraic identities and algebraic expressions and identities. If you have not watched the theoretical videos where I have covered this chapter thoroughly in the other playlist, CBSE Maths 8 RS Agarwal, I strongly suggest and request that you watch those videos also if you need to have a good understanding of the concept of these chapters. And always look out for this playlist, that is Maths 8 hot means a high order thinking problem, where I come up with 10 a set of 10 good problems which are harder problems based on every chapter that are completed in the other playlist, CBSE Maths 8 RS Agarwal. So if this video was beneficial to you, then please like it, share it with your friends, and also support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. So keep looking for the next set of problems on this chapter and other chapters. In the other playlist, CBSE Maths 8 RS Agarwal, I will soon start the next chapter, that is factorization. So please stay tuned for the upcoming videos, and thanks for watching, and until the next video, take care and bye.